Hi everyone, this is session 1 on Unit 1 of our Math 121 trigonometry class. So the idea is that these are the class notes that you will see on Blackboard, and for those of you who are either not able to attend on either the Tuesday or Thursday sessions, or uh, you know, actually showed up for the Tuesday, Thursdays, but now there are some questions and you need to refer back. I'm hoping that the audio over the notes will help you. So let's start this very quickly. This is a trigonometry class. So we're going to start with something very basic. So trigonometry is just the study of the relationship between the sides and angles of any triangle. So in this course, we're going to look at right triangles, obtuse triangles, acute triangles, their size and their measurements, and just the relationships. So let's start with angles, right? So angle measure. An angle can be measured in two ways. The first way you're all familiar with. The first way is if I measure it as a degree. So basically each time I turn, it's 1/360th of a rotation. Because if I do the entire circle, it comes out to be 360 degrees. So that's the first measure. The second one's going to be a little bit weird because it's not one that we usually do when in the middle school or high school when you took it way back when. The second one method is to measure angles as a radian, and unlike a degree, where it's a rotation, a radian is just a comparison of a circle's arc length to its radius length. Some definitions here, right? So we say that an angle theta, because I use this symbol quite a bit, it's just the Greek word for angle. We say that theta is defined to be 1 radian. Now 1 degree is 1/360th of a rotation. 1 radian is if the arc length is equal to the radius length. We have a formula for that. We use theta is equal to S over R. S is the arc length and R is the radius. So I have some examples for you. So if we look at right over here, right? So here's my angle theta. This is the arc length. The arc length would be if I could just do a circle out of string and then kind of just cut out parts of that circle. So if I have an angle theta in which the radius measures exactly the same as the arc length, then we say by definition that this theta is equal to 1 radian. So notice the ratio S over R, 1 over 1 is just 1 radian. Now we go over here. You notice that my radius is 3, my arc length is 6. So when I put into my formula 6 over 3, I get that this is 2 radians. And then here my radius is 4, my arc length is 2. So when I do S over R, my theta in radians is 3 over, oops, sorry guys, I was typing it. It's going to be 2 over 4, which is 1/2 radians. Now again, what does that mean? Well, here's what it means. It means that my arc length is equal to the radius, right, a 1. Here it means my arc length is 2 times the radius. And here it means that my arc length is half the radius. So that's what that radian measure is. It's kind of weird to think about, but this is just a relationship. And when I measure angles in radians, whether or not I actually write the word radians is not important. In the same way that if I had the number 3, I can put a plus sign in front to show it's a positive 3, but I don't have to. Same thing with the radian. If I just see that theta is equal to 1/2, it's understood to be 1/2 radians. Right? Right, so that is what this first slide is on. So let's go ahead and look at the second one. So now I want to talk about the relationship between degree measure and, give me 1 second, degree measure and radian measure. Right, so here I have my two circles. And one circle we'll talk in terms of degrees. We'll talk in terms the other guy of the radians. So I want to establish some kind of relationship so that I can convert angles from one unit to the other unit. So let's come over here. So we said that in a circle, I have 360 degrees. So that's right there. Now with the radians, see if you can follow with me on this one, right? The formula for radians is just S over R. The angle is the relationship of the arc length to the radius. Now, think back a little bit to geometry. So when we say the arc length, but the arc length, if you look at the outside, that's just the perimeter, right? The outside or the circumference of my circle. And the formula for the circumference of my circle is 2 pi r, 2 times pi times the radius. So if I replace the s, which is the arc length, with 2 pi r, the circumference of that circle, and then the r is still here, notice that the r cancels out. So then that leaves me with just this. 360 degrees is equal to 2 pi. And if I solve for pi, dividing by 2 on both sides, I'm going to get that pi is equal to 160 degrees. So that is a relationship between radians and degrees, right? That pi equals to 180 degrees. Now, just one more thing. So we have said that in degree form, that pi is 180. But if I actually wanted to look at this in terms of radians of the arc length or the radius length, then pi becomes that 3.14159 irrational, never-ending value, irrational number that you're familiar with. Anytime I work with the symbol pi in this form, I need to use the entire symbol on my calculator. And again, here is just, again, we said writing radian is optional. If an angle has no degree symbol, it's assumed to be in radians. So what's really important is the degree symbol that you have to add in. Just like if something is negative, you have to add that in. But the degree symbol, but the radius, the word radian, not so much. Okay, so now let's go down to here. So now I have my conversion factor. My conversion factor is going to be made up of this particular equivalence. So 180, let me just put this eraser back. It's driving me nuts here. Okay. So I can either do 180 degrees over pi or pi over 180 degrees. Notice if they're both equivalent, if this equals to 1, this equals to 1. Okay? All right. So let's do some stuff. Let's convert from radians to degrees. I want you to notice that if I'm trying to get the answer to be in degrees, I want to work with a conversion factor that actually has degrees on top, because that's the unit I want my angle to be in. So if I wanted to write pi over 2 radians in degree form, here's what I have, pi over 2. I don't need to include radians because that's just a unit being measured. But pi over 2 times my conversion factor, 180 degrees over pi. Pi cancels out. So all I have left is 180 degrees over 2, so 90 degrees. So pi over 2 radians is equivalent to a 90-degree angle. I go to B. I have pi over 3 radians. Again, pi over 3, I multiply by 180 degrees over pi. The pi cancels out. So this is 180 degrees divided by 3, or 60 degrees. Then I have 3/5 pi. Again, 3/5 pi, 180 degrees over pi. The pi cancels out. So when I multiply 3 times 180 divided by 5, I end up with 108 degrees. Okay. Do you notice, by the way, that in each of these, the pi cancels? If that's the case, I want you to notice that there's a shortcut. And the shortcut just being that really what's happening. This pi over 2 becomes 180 over 2. This pi over 3 becomes 180 over 3. And this 3/5 pi becomes 3 times 180 over 5. So you're really just replacing pi with 180. So if you wanted to do that, here's what I could do. So for example, if I had to convert 4 pi radians, I just do 4 times 180, and I get 720 degrees. The same answer I would get by multiplying by 180 degrees over pi, with the pi's canceling out. All right, so ladies and gentlemen, at this point, here's what I'm going to do. I find that if the videos get to be too long, there's a problem uploading it. So what I usually do is I just break them up. So feel free to go ahead and end this session now. I'm just going to save this as session 1, video 1 of 3. There are 9 slides to this, which sounds a lot worse than it really is. But this way it can save very nicely. So go ahead and just exit out. I will see you in video 2.